Hey guys, welcome back. This is a continuation of the previous introduction to continuity that I posted. But in this case, we're just gonna go over briefly the definition of continuity on a closed interval. So before what we talked about was continuity on an open interval, and one of the points that I made there was that on an open interval, right? It's kind of ugly. On an open interval, maybe from A to B, we don't include the endpoint. So no endpoints. Okay. But now if we have some sort of graph and we have some function and we say, all right, let's take a look at it on a closed interval. Say this is A to B, and we say, is this continuous on A to B, right? Well, if this were an open, the conditions for continuity on a closed interval is that it obviously has to be continuous on the open interval. Because what that really means is that, wow, on an open interval, the same, right? If this was A and B, the same ones, but now with open, all the points in here would have to be included, and the same applies here. But now the exception is that we can't include the endpoints. So we'll say right here, right? We don't include them in an open interval, but on a closed interval, we certainly do. And that's really the key to understanding the difference here. So here we say, well, we said, is this function continuous on the open interval? The conditions are that we say maybe we choose a point, A. What is the limit of the function as it goes to A from the right side? Well, that means that we're including the endpoint here, and the limit is f of A. Okay? And it says another condition is that the limit as x goes to B on the left side, which is the other endpoint, has to be f of B. So we are including the endpoints, and they're defined. So yes, this function is continuous on a closed interval. And this is an arbitrary example. I didn't really pick one with a polynomial or anything, but the point is that we have to evaluate them, on the endpoints when we're looking for continuity on closed intervals, not here. Not here, okay? Here, if we said, is this continuous on the open interval? It is, sure. And we don't care about A and B, which are the limits, or the endpoints, sorry. Be careful with our terms. We're not interested in that. Somebody might look at this and say, no, this is discontinuous because there are holes on A and B. And they wouldn't be right because this is an open interval and we're not interested in those points. So, thank you for watching and keep following a couple more videos.